Hi everybody, you are welcome to Rockpaw Data and Digital Lab YouTube channel. My name is Rockpaw. I am an analyst, data analyst, digital analyst, marketing analyst, and also a business analyst. I use several tools. I use Python, Power BI, Looker Studio, Microsoft Excel, Google Analytics, BigQuery, SQL, Google Ads, just name them. These are the videos that you'll be coming across in this YouTube channel. Marketing analyst means marketing model, marketing attribution model, everything you will find them in this video, in this YouTube channel. In the first video, we talked about data pre-processing part 1, and in the second video we talked about data pre-processing part 2. Please, you can check out the video and see what we did there. So that will really be useful because we'll be picking up some things here. We are not going to be typing everything from the beginning, so we are going to be copy and paste something, so we don't have to at least start it from afresh. So if you are interested, please just go to the video and please don't forget to like, don't forget to subscribe to this channel, don't forget to share. Your contribution is needed, your support as well is needed for this YouTube to grow. I will really appreciate that. So what do we do now? First, we come back to our data pre-processing part 1. So this is our data pre-processing part 1. So what we are going to do here, we are going to copy our something here. So we come back to our machine learning model, so we put it here. So this is our library, so we import our libraries. We are using NumPy, and we are using pandas as well. We are using matplotlib. So I've already explained the reason why we are using this, so you can check out the first videos for you to really got in-depth knowledge of it. So we have to run it, and let's see if everything works perfectly as we can see. So our library is, we have already imported our libraries. So the next thing we do is we import our data set. So as I've said, you can use this lecture on all your projects. So you doesn't have to probably need a particular data set in order for you to be able to carry out your project. But if you need exact data set in order for you to follow, that is not a problem. Just put it in the comment section. I'm going to provide the data for you. So we are going to name our data as data set. So then we are going to make it data set equal to, so we are going to be using pandas to read pd.read. Then we are going to make it underscore CSV because I'm using a CSV file. So, and the name of our data set is salary data.csv, salary data.csv, because that is, the data is in CSV format. So then we run. So this is why I'm running it here, so that you can see how I run it. I can as well run it from a keyboard. Running from a keyboard is going to be Control Enter. With Control Enter, I've already run it from a keyboard, and I can as well run it here, which is Run Cell and Advanced Shift Enter. So as I've said, so depends on your keyboard. So what do we do now? We want to view our data set, and let's see what we have in the data set. So dataset.head, so that is just what you need. So it will give you 5 columns and 5 rows. So we are having years of experience, and we are having salary. So these are the things we are going to be predicting in this our simple linear regression. So if we want to see further, probably we can put it inside 10 heads. So putting as 10 heads, so we can see we are having 10 rows and 10 columns, because it normally start from is 0. So 0 is the first, 1 is the second, 2 is the third. So the data is well cleaned, so we don't have any missing data, we don't have any NaN, not a number like the first video data processing. I use that to teach, to teach us how to clean our data if we have unclean data, or we have a missing data, or we have something that is not probably not a number. We all categorize them as unclean data, or you call them a missing data. So now we've seen our data set, so we want to predict year of experience to their salary. So who got what? So probably 1.1 year of experience, your salary is this. If you are getting 1 to 3 years experience, your salary is this. 1.3 years experience, 1.5 years experience. If your experience is 2 years, this is your salary. If your experience is 2.2, this is your salary. So that is what we want to predict in this simple linear regression. So as I've said, you can use this across every of your projects. So what we're going to do now, we are going to probably distribute it or divide it into X and Y. What does that mean? When you check the first video, we see we have dependent variable and we have the independent variable. So we are going to put the independent variable in X, and we are going to put the dependent variable in Y. So we are making our X now, because our X is the independent variable. So our X equal to our data set. So we're having our S equal to our data set. So and we are using .iloc. So that is what we'll be using, .iloc. So dataset S is equal to dataset.iloc. So, and what does it mean? What we are trying to do is we need the first and except the last. So we are taking all the first row and column. So we are having the first row and column except the last one. Except the last one. And what is that? What does that mean? Except minus 1. So that is the last one that we don't need. So we are taking the first one except the last one. So, and we're having our Y. So our Y equal to dataset as well. So we can easily copy this. So we don't have to continue writing or typing, so we can easily copy this and put it here. So we are having our dataset, Y is equal to dataset.iloc, and remember in this case, so we are taking the first one except, we are taking the last one except the first one. So we'll be removing this from, we don't need this. So we'll be removing this. So, and when we run it, let's see what we get. Okay, let me try to add some cell here. So we print our X to see what we have there. We print our print X. Let's print our X. You can see this, our S is this years of experience, which is the independent variable. So what we are saying is we need all the column and the row of dependent variable except the last one. That's why we are making it -1. So except the last one. That is why you see it's not including the salary. But in the case of y, which is our dependent variable, so what we are saying is we are taking this except this. So we are taking this except this. So because we are reading it back, so except this. So let's read our y and for us to see what we have there. So print y. When we print our y, you can see in our y we are having the salary. So you can easily apply this to all your machine learning projects. So if you have more than probably you have up to 10 rows and 10 columns, or you have up to 20 rows and 20 columns, you can easily apply this. So what you do is the last one, everything still work. You can go to data preprocessing part 1 and you will see what I did there. So you can easily use this video across all your machine learning projects. So that is why it's applicable in every area of our project. So what we are going to do is we are going to split our data sets into training sets, and we are going to split it into test sets. So the question is this: why do we have to split our data set into training set and test sets? Why do we? Some people may ask, why do we train our data set into training set and test set? Well, this is the training set. The training set is what we want to use. Is the main something, let me put it that way. The test set is what we want to, the percentage of the data we want to use to test our prediction. So we pass the training data, probably you call it now, I'm going to write it out. So the S train and the test train. So I mean the S train and the Y train. So we pass train data, the S train, the Y train during fit, so that our model will fit past the parameter that build the relationship between the independent and dependent variable. So that is why we are splitting our data. So we are splitting it to a train and to a test set. So we are training this and we are also going to test this particular amount of data that we want to use. So training our data. So what are we going to do? We are going to import the library for splitting the data set into training and the test set. So from scikit-learn, or you call it from sklearn, from sklearn dot model selection dot model underscore selection model selection. What we do is we import train test split. Import train test split. So that is what we have to import to split our data sets into training set and test. So we are dividing them. So you can use the word training, split, or you use the word divide, but we are splitting them into two parts. So a training part and a test part. So what follows next, we are going to, in that training set, we are going to have two, which is going to be our S train and our Y train. In the test part, we are going to have our S test and our Y test. So we are having 4 in addition, 2 from the training and the 2 from the test. So I'm going to explain this further to you. So we are having our S train now. So we are having S train. Our S train will give us, so we have S train, then we have S test as well, as I've said. So S train, S test, Y train. So we're having our Y train, and we're also having our Y test. So this is what we are having. So we are going to pass it equal to train test split. So train test split. So we can copy this and put it here. So this is our S train, this is our S test, this is our Y train, this is our Y test. So into this, I'm going to explain this further. Then we are going to have our bracket opened. Then we are going to have our X and we are going to have our Y. In between, then we are going to have our test size. Our test size is going to be 0.2. Probably we are using is 0.2 for our test size. Then what follows? Then we are going to have a random state. A random. I'm going to explain all this in a jiffy. A random state. Our random state is going to be 0. I'm going to have a random state of 0. Now, before I run this, so we can see, so from scikit-learn.model selection, we import train test split. Then we have our S train, S test, Y train, Y test. So we have 2 from the training, then we have 2 from the test set as well. So why do we have that? Now, Y test contain, I'm going to talk about the Y test. Now, I know I've already explained the train set, that why we pass the S train and the Y train. Now, I can also re-explain that. Now for the Y test. For the Y test. So this Y test. For the Y test, we are going to talk about the Y test now. Y test contains the target output. This Y test, it contains the target output. Let's say, for instance, now we want to analyze about a disease. So disease, we can say disease is equal to test data. So this Y test contains the target output, what we want out, what we are targeting out, corresponding to S test. You understand? So it is just the target output corresponding to the S test. So this Y test is the output corresponding to this S test. You understand? So already remember we have our here we have our X and also we have our Y already, which is our independent variable and our dependent variable. So from our X we also have another one, and from our Y also we also have another one. So in this our Y test now, so Y test is the output that is corresponding to this S test, and will be compared to predict value with given S test. So whatever we get from the Y test, we are going to compare it to the given S test if what we have is corresponding, because we want to predict something. So whatever we are getting from the Y test, we want to compare it to the S test if what we got there correspond, if makes sense, if equals the same thing, if it's similar, if it's close. So that's why we are saying we be compared to prediction value with given S test value of the model after we have trained it, in order to determine how successful the model is. So now probably let's print this one out and let's see. For you to get more knowledge of it, please, you can always Google. That will really be of a print. Let's print our S-train now. We are printing our S-train for us to see. Print S-train. Pum 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 pum. So that means wrong. Save 99 line 1. So what is happening? So that means we have not run this. So we have to run it. Let's run it and see. Okay, it's fine. So it's because we didn't run this cell. So let's run this now. Okay, now. So look at the years of experience S-train. When we come back here, you can see we are having the years of experience. These are the years of experience. Now come back to this. You can see. So we are having our years of experience here, which is from our string. Now let's try to print our s-tests before going to white string. I'm going to also explain that better. So print s-test. Now you can see this is our s-test. And remember what we said. We are using a 0.2%. Probably just like this. Let me come back to the string. Now let's just say we are using 1, 2, 3, 4, 5, 6 or 7, 8. So we are just using a few percentage of the total data, you understand, as a test side. So we are using the whole is probably out of the training set. We are just using 0.2% as a test size. So the remaining 80% goes to our training set. So we're only having a 0.2. So that is why we are having a shorter experience. So we only have a 0.2 of every total of the data set we are having. 0.2 as test size. So that is the amount we want to use. And 0.2 is just 20% of the total data set. We are using 0.2 as our test size. And the random start. Now, we may ask, so why are we using the random start to be 0? Then what is the random start? Random starts are parameter in the train test splits function. It controls the solving process with random state none. Probably if we decide to put it here, probably we decide to use a random state of none here. Probably we are not using a 0 and we are using the random state of none. If we are using a random state of none, we get different training and test sets. So if we are using random state none, so definitely we are going to get different train and test sets across different execution and the solving process out of control. So the solving process, it will be out of control. So that is why we don't want it to be out of control. That is why we are using 0. And why are we using 0? Random state 0, we get the same training and the test sets across different execution. So when we use a 0, we are getting the same training and the test sets. So we are not going to get, probably we are getting -1 here and we are getting -3 here. Or we are getting -2 here and we are getting -0 here. So that is why we are using the random state to be a 0. I don't know if you understand this better. So now we are going to print our string as well. So we've already print our string. Let's print our string and see what is there in our string. So you can see, don't forget that our string is from the salary. I mean our white train. This is our Y. So our white train is from the salary. So now what we are going to have is we are going to have our white test. And let's see. And let's see our Y test. Now let's print our white test. Print. White test. And you can see this is our white test. We are just using 20% of the total data from the salary. From the salary, we are taking or we are picking just 20% as a test. So don't forget that our Y is the salary. Y, our S is the experience, is the years of experience. So from the years of experience, we are using 80%. Then the remaining 20% is for testing. You understand now? So out of the 100% in these years of experience, we are just picking probably 20%, probably 1, 2, 3, 4, 5, 6, 7, 8, whatever. So we are using this as a test. So that is why we are having our S test here. S train, we are having our S test. So just 20% of it as a test. Then our white train, this is our white train. The white train is the salary. Remember we split it now. This is why we split the data, splitting the data set into training set and test set. So we split this. So we remove 20% from these two data from the Y, which is our salary. So when we come back to our salary, this is the salary, the white train. We only pick 20% as a test. So we want to use 20% of it as a test to see if what we are going to predict is going to be the same thing as the original data that we have, because we want to know if someone that has experience of 1.1 years of experience actually got this salary if we predict it. So the next thing we do is we go to our training the simple linear regression model on the training set. Now remember, we have our training set. This is our white train, this is our S train. So that is what we are going to predict. We are going to train our simple linear regression on the training set. Now we are not touching the test set yet. So we just want to train the simple linear regression model on the training set. So what should we do doing that? We are going to also import some libraries, because without that we will not be able to actually do that. So I would like to run this thing once again from together. So run all cells. So I would like to run all the cells, all the cells, all the cells, all the cells, all the cells. So I've run all the cells, white test, white train, print white train, white test. Everything is completely run. So this is our white train. So this is our white test. So now we are going to train the simple linear regression. So from scikit-learn, as usual, or you call it from sklearn dot. And you may be asking, how did I able to get this? Did I put it offered? Sometimes if you have been doing machine learning model, most of the libraries you don't have to. Sometimes you just know it without, it's something you remember easily because you have been using it, or you can easily go to Google. I think in one of those videos I'm going to put it there for us to see. So you can, from your Google, you can just put it there. Training simple linear regression model algorithm, library for training simple linear regression, is going to put it there. So what I'm going to do from scikit-learn dot linear model. So this time around is going to be linear model. So we are going to import linear regression. Import linear regression. We are going to import our linear regression. So from the what followed, then we are going to have a regressor. We are going to have regressor. Our regressor, we are going to pass it to be regressor is equal to the linear regression that we have here. So that is our regressor. So we're going to have it as linear. So then what follow again? we are going to have our regression again. We are going to fit. We are going to fit our regression. We are going to fit. So regression dot fit. In this time around, we are not going to transform. In the data processing, we transform. Please, you can go back to the video and watch it again. So we are not going to transform. We're only going to fit. So what are we going to fit here? We are going to fit our S train and also our Y train. So fit S train, Y train. So we are going to fit our S train and our Y train. So we can run it. Let's run it and let's see. Invalid from scikit-learn.linear model. Import linear regression. Import linear regression. So what we are trying to do is to have to put. So always try to read what the error is saying. From there you can easily, because it will point where the error is, so you can see it's telling us that we don't have to put a bracket there. So let's rerun it. You can see we have our linear regression. So already we've trained our simple linear regression model. So what should we do next? We want to predict the test set results. We want to predict the test set results. So what should we do now? Predicting our test set result. We have our regression dot predict. So we can always copy. There's nothing wrong from copying. We can always copy dot predict. So we want to predict now. We want to predict. Please check the spelling. Check the spelling. If the spelling is correct, predict. So we are going to predict. And what are we going to predict? We are going to predict our S test. We are going to predict our S test. Now, that is all we have to do. Now, is that really all? No. Let's come back to our S test and see what we have in our S test. Now, this is our S test. We are having 20% from the years of experience. Just 20%. And we want to predict this 20% to see if we are going to, we want to test it so that we are done, if we are going to actually get the actual prediction from the years of experience. So now let's pass it. We are having, let's make it probably our Y predicts, because that is what we want to predict. Our Y predicts. So we want to predict our Y. So Y predicts is equal to regression.predict x. Now let's run it and see what we're going to get. Everything is fine. Then let's print this and see. Print your Y predicts. Please try to close this little space there. So print. So that's what I said. It will always give you where the error is. That is why I love Jupyter Notebook. Jupyter Notebook will indicate where the error is. It will point an arrow, tell you there is an error, and name error, name, print is not defined. So we don't put T. I forgot to put T. So let's run it again. You can see. You can see. So this is our Y predict. So we are going to visualize it. So visualizing the training set, visualizing the test set results. Now, we want to remember we've already trained our regression model, our linear regression model on training set. So we've already trained it. Now we want to visualize it. And when we visualize it, we also want to visualize the test result to see how far are we able to capture anything from the training set. We want to predict. And remember that a linear regression is going to give us a straight line. So we are going to have a straight line. So we want to see how many we're able to capture, how close are we to the actual result. So this is what we really want to look at now. So let's visualize it and let's see what is happening. Now we are going to use PLT. When you come back to, let's go up and see. Now import matplotlib.pyplot as PLT. So we only need this PLT. So the PLT is what we need to visualize. So we are having the PLT, our PLT.scatter, because we are going to use a scatter plot. PLT.scatter, then we are going to pass our S train and our Y train. So S train, Y train as well. Then we are going to have a color to it. So we are having a color. Let's have a color of, I think red will be good. Let's have a color of red. So remember to close the bracket. So PLT.scatter. So we want a scatter plot. So our S train and our Y train color is going to be red in that scatter plot. So, and the next thing we are going to do also, we are going to use also the PLT. Continue with the PLT dot. Plot, because we are going to plot it. PLT dot plot. Then what are we plotting? We are plotting the S train. We are plotting the S train. Then what follows? Regression dot predicts S train, because we want to predict it. So regressor dot predict. Regressor dot predict. What are we predicting? We are predicting the S train. S train. Then we need a color for it. So color predicts S train. So we are having a color of blue. A color of blue. So that's going to be the line. So when we'll run it, you will see color equal to blue. So we are using blue. You can as well use any color you like, any color of your choice. So we have that already. Then what happened? Then we are going to put title. We have to put the title to know our, Y and X. So because we have to make it Y and X. So, or X and Y. So Y row, we have to vertical and S axis, Y axis, X axis. So that is why we have to use a title PLT dot title. So we are using PLT for everything. PLT dot title. The title is going to be salary. The title is going to be salary. Salary versus, I think it should be salary versus experience. Let's make that one. salary versus experience. So what is going to be that? Is going to be our test set. I hope you are getting this. Test set. So then what follow next? What follow next is, don't forget to put a bracket here. And what follow next, again, we are going to put our S label and our Y label, plt dot S label. So what's going to be our S label? Our S label is going to be years of experience. If you already decide that means you're right. Years of experience. So that's going to be our S label, I think, yes. So then what is going to be our Y label? So we can just copy this in order for us not to take too much of time. Let's copy this and let's put this here. So we are just going to change the S to be the Y label. So what's going to be our Y label? You can also guess as. So it's going to be our salary string. Then we need a color for it. So color predict a string. So we are having a color of blue. A color of blue. So that's going to be the line. So when we'll run it, you will see color equal to blue. So we are using blue. You can as well use any color you like, any color of your choice. So we have that already. Then what happened? Then we are going to put title. We have to put the title to know our Y and X. So because we have to make it Y and X. So, or X and Y. So Y row, we have to vertical and S axis, Y axis, X axis. So that is why we have to use a title plt dot title. So we are using plt for everything. Plt dot title. The title is going to be salary. The title is going to be salary. Salary versus, I think it should be salary versus experience. Let's make that one. Salary versus experience. So what is going to be that? Is going to be our test set. I hope you are getting this. Test set. So then what follow next? What follow next is, don't forget to put a bracket here. And what follow next, again, we are going to put our S label and our Y label, plt dot S label. So what's going to be our S label? Our S label is going to be years of experience. If you already decide that means you're right. Years of experience. So that's going to be our S label, I think, yes. So then what is going to be our Y label? So we can just copy this in order for us not to take too much of time. Let's copy this and let's put this here. So we are just going to change the S to be the Y label. So what's going to be our Y label? You can also guess as. So it's going to be our salary. It's going to be our salary. It's going to be our salary. So we, as I've said, maybe let's see I think everything is correct. So visualizing the training set results. So we have visualizing the training set results. So, and salary, everything is right. Years of experience as our S label. This is Y label. This is, I think everything is right now. Let's try to run it and see the outcome. Oh, good. So you can see, this is our actual data. This is our visualizing our training set result. You can see how many were we able to capture. You know, this, I can say this, I can say this, I can't know. I can also, should we count this and this together? But mainly is this and this and this. So we can see. So when we check a 10,000, someone that has between 1.1 years of experience, let's go up and see 1.1 years of experience. 1.1 years of experience. 1.1 years of experience, the person is getting 39,343, approximately 40,000. Approximately 40,000. That is 1.1 years of experience. So you can see 1.1 years of experience. So approximately 40,000. When you see 39 point something, so something like that. So we come back here. Let's check again. Someone that has 1.3 years of experience, the salary is 46,205. 46,205, 1.3 years of experience. So 1.3 years of experience. So that is 40 something thousand. So we can easily see it within this something, because this is 2 years already. This will be 3 years, this will be 4 years, this will be 5 years, it will be 6 years, 7 years, 8 years, 9 years, 10 years of experience. And we are having years of experience. We are having people, we are having people with how many years of experience? We are the main data. We are having people with 3.7 years of experience. So when we view the data forward, we can see. So what next should we do now? So we are going to visualize the training set. So we want to predict if we are getting similar to, or what are we able to capture in the original data. I think we can just copy this. Let's copy everything here. It copies everything here, and let's put it here. Now, what do we have to change here? We have to change test y test. So you get it right. So you have to change s test. So just make it here s test, and you also have it y test. Y test. Then our column still remain red. Then you can leave this like that. You don't have to change anything here. So this is absolutely good. So you don't have to your regression dot predict s train, y train, everything is perfectly good. Then we come back to our title. Our title still remain salary versus experience, the set. So this is going to be training set. Training set. That is going to be our, so years of experience, yeah, salary, yeah. There's something we forgot to put, but still it work. So we can actually put plenty dot show where without putting it, it works. But in case it doesn't show, please try to remember to put plt dot show. Remember to put that, but in case if it doesn't, so I'm going to run everything together. You can come here, run all cells. Let's see. So we are able to at least we are able to get something similar, at least something. So we are having a good result, if I may say. This is years of experience. So we are able to pick one. I'm just 1, 2, 3, 4. This falls within this range, so this is going to be 1 point probably 3 or 1 point something years of experience. So we have come to the end of simple linear regression. The next lecture will be going to multiple linear regression. Please stay tuned to this YouTube channel. You are going to be learning a lot when it comes to machine learning. You are going to be learning a lot when it comes to Power BI. You are going to be learning a lot when it comes to Looker Studio, Data Studio now, Looker Studio, dashboard. You are going to be learning a lot when it comes to Microsoft Excel, functions, building dashboard with Excel, everything about Microsoft Excel. You are going to be learning a lot about Google Analytics 4, setting it up, everything about it, Google Tag Manager, Google Ads campaign, so many things, marketing attribution model, so many things. You are going to SQL, BigQuery, everything will be coming one after the other. Please don't forget to subscribe,